Hello students, today we are going to discuss electronic spectra of transition metal complexes, which is a very important topic of inorganic chemistry, especially for master students and also for any competitive exams like NET or GATE. Okay, so let us first understand that what the title of the topic means. Okay, so electronic is obviously related to electrons, right? And spectra. Spectra is the plural form of spectrum. What is spectrum? This is one image of UV visible spectrum. Now spectrum or spectra there are many kind of spectrums, but here I am showing you UV visible spectra, which is related to our topic. Okay, this is an image of a spectra. Now and transition metal complexes, so all of you know what are the transition metals, and complex means when they are ligated to a different ligands they make complexes. So we have to study here the spectra generated by a transition metal complex. So here this example of one transition metal is given. The spectra generated by this metal is this one. Now we have to, and this is generating due to the transition of electrons. That's why it is electronic spectra. So there are many kind of peaks will come in different regions. So describing these peaks and energy transfer in a transfer of electrons from which energy level to what energy level, so that one is important here to describe. Okay, so let us go to the next slide. So last we should also know why we need to know about this topic. Okay, so because if we are editing about a topic, so it is also important why we need to know about this topic. Okay, now this I think are you familiar with these gemstones? So you know there are various precious gemstones with a different color. Those are available. Many people, according to astrology, they wear in their as a ring on their fingers. Okay, so I think many of you also maybe use, mainly Indian people, they are a lot of use. Okay, now as a chemist you should know why the color of these gemstones they are having these nice colors. Okay, like ruby or emerald. Ruby is red, emerald is green in color, and sapphire is blue in color. So why they are so nicely colored? What are the source of these colors? So if you know about this topic, you can also explain the color of this topic. So you can tell your friends or other families or other known persons that you know that why it is generating the color here, it is generating. Okay, so like this is an example of a ruby I am taking. Ruby, you know what is the composition of ruby? Ruby is nothing but alumina crystals. Okay, but it is doped with the chromium 3+N. So you can see this is an image of an alumina crystal made of aluminium 3+N oxide ions, but this is colorless right, and this is not so attractive. Okay, you will not wear these as a gemstone, but when you dope it with the chromium 3+N, so if only 2% of aluminium 3+Ns are replaced by chromium, doping means very small amount of chromium you have to add here, but if you add, obviously it will replace some aluminum ion, otherwise inside the crystal, so their crystal charge is balanced, so you have to remove some aluminium 3+N so that to replace it with chromium 3+N. But here you see the chromium 3+ is actually chromium is a transition metal, so this thing is related to transition metal. So when it was not a transition metal like aluminium 3+, so it was colorless, there was no color. But when you are adding chromium 3+N, you see this nice red color, which is also used as in the ring, okay, as a precious stone. Now the color of this ruby is generating due to chromium 3+N. So color of a complex is generating due to the transition metal ions present in it, and also it will show a spectrum at the same time. Okay, so the color and spectrum both is generated due to the transition of electrons. Okay. So you can see here the aqua complexes means water. Here when ions transition, these are all transition, first row transition metal ions, and they are dissolved in water, so they will make aqua complexes. Okay, and you see they are showing very nice colors. Okay, only manganese is, it's not colorless, it's colored but very light pink color. So by knowing this chapter, you can also explain why these different transition metals showing different colors, why they are sometimes deep in color, sometimes very light in color, and also the spectra what I showed you we can also explain those things. Okay, so that's why this topic is very, very important part of inorganic chemistry. Okay, so normally you tell me that what is the science behind color of an object, because we see colored objects around us. Some is red, some is blue, some is violet, green, yellow. So we are seeing different colors. So this is our colorful world. We are seeing many colors. But you know why we see one color, means like red color is red, blue color is blue? Do you know that one? So for knowing that one, you should, I think you already know about the electromagnetic spectrum. So the light which is coming from the sun to us, that is electromagnetic spectrum. So it looks like this one, and one part is visible region, where visible light composed of 7 different color absorb. You know all these things. Now if any object it absorbs any color from the visible light, then it will show the color which is complementary to it. So what is complementary color? So if we put all these colors in a color wheel, okay, like this, then the complementary color will be the opposite side color from this one. Like red will be a complementary color of green, and vice versa. Like green will be complementary color for red, yellow and violet, orange and blue. That means if a compound absorbs red light, it will show you green color. So that means the green, the leaf of a leaf which you see around us, so those are green in color because they are absorbing red color. Okay, like yellow color or blue color. So same, if it is absorbs orange color, it will show blue color. If absorbs blue color, it will show orange color. So this is the funda of a complementary color. So that means the compound, whatever compound or object that should absorb one color from the visible region, then only you will see the compound or object as a colorful. Okay, one color you will see. Okay, now so similarly, when you see here our aqua complexes, I am showing here no first transition metal. So that means one is red, means it will show green. So which you are seeing as green, so that means it is absorbing red color. Okay, then here yellow, that means it is absorbing violet color. Okay, so that means electrons will absorb color from the visible region and it will go to higher energy level, obviously. So inside also this thing will happen. Electron will actually the color for our complex, in case of our complexes, because we are concerned about the transition metal complexes, color will be absorbed by the electrons inside the transition metal complex, and it will go to higher energy level, like, okay, and then you will see the complementary color. Okay, so for that you should also know about the transition molecular orbital diagram of transition metal complexes. Okay, so like it is okay, this whole explanation I'll give it later, but these are the different energy levels when they are making. So you know, when atoms combine, two atoms combine to make a molecule, then they form molecular orbitals. These are the atomic orbitals in different energy level of metal ion. These are the atomic orbitals of the ligand. So when they combine they make a molecular orbitals. Okay, these are the different molecular orbitals. And here what happens when you give visible light on that complex, then electrons from the lower energy level, they will absorb the light, it will get energy, because light is finally is a form of energy, is a photon, right? It's a packet of energy. So it will absorb the photons, or it will absorb the energy, then it will go to higher energy level. So electron will transit from lower energy level to higher energy level. That's why we'll see the color of the complex, and as well as we'll get the spectra, because absorption is happening, so you'll get absorption spectra. So, and which transition is happening, we have to identify. Like there are various kind of transitions possible in a transition metal complex, like LMCT, ligand to metal charge transfer, DD transition, metal to ligand charge transfer. So LMCT, MLCT and DD transition, mainly these three types of transitions are there. So if this type of transition is happening with the electrons after absorbing light from the source of light, like normal light, then it will show color and spectra. So we have to explain those things in this topic of our discussion. Okay. Okay, next I'm going to discuss about the aim of this chapter. Okay, first, so I'll go to later. I'll start this.